Hello there, my name's Alistair, and I'd just like to thank my colleague Lindsay for covering the introduction to the company and for introducing our brand new product, the SUPR-CM. So for the rest of the presentation, I'm going to be taking you through some of the applications which the SUPR-CM is applicable for. The two main areas we're interested in are the formulation area and the antibody engineering area. So when we're thinking about antibody engineering, we have a situation where we've generated a large number of different antibodies, and we want to know which one is the most stable, establish what the most suitable candidate is for the rest of the biologic drug development program. And the challenge here is trying to run through all these different samples quickly, efficiently, whilst also getting high quality data so you can make the best decisions about which candidates to progress with. There's then also a challenge in terms of having a rapid turnaround time so that when you've got a new batch of antibodies to process, the system's able to keep up the pace with you. Then when you've established a stable candidate, you then want to move into the formulations area. And this is where you're trying to alter the solution conditions in order to maximize the stability of the antibody. Now, the challenge here involves the large number of different variables that you can alter in order to increase the stability. This could involve the buffer solutions, this could involve changing the pH. There's other excipients you can add like salt or sugars that can increase stability. And there's also things like ligands that you could add as well. And so you need to be able to process, generate samples that test all these different areas, um, and do that quickly and efficiently so you can work out what the optimum formulation conditions are, so you can push on with the rest of the development. So since we're talking about formulation, let's move on with the first example, the formulation example. So in this particular case, we're going to be looking at the stability of an IgG1 monoclonal antibody. We're going to be unfolding this antibody with the denaturant guanidine hydrochloride, and the particular formulation condition we're interested in testing here is the effect of pH with a citrate phosphate buffer. And we want to find out what the most optimum pH is for this particular antibody. We'll utilize a 384 well microplate format and using 24 denaturant concentrations from 0 moles up to 6 moles with 3 replicates and a total well volume of 50 microliters. In terms of the measurement and analysis side of things, we'll measure the plates in around 2.5 minutes. That way we can have a rapid measurement time without compromising on the quality of data. Then we'll look at the ratio of intensities at 355 nanometers and 330 nanometers in order to calculate the fraction unfolded, which we can use to fit our three-state model to. So here we have our first plot, which looks at the fluorescence spectrum generated from the SUPR-CM system. Here we've highlighted the two extreme denaturant concentration cases, 0 moles up to 6 moles denaturant, and you can see that when the denaturant is added, we get a shift in the fluorescence spectra towards higher wavelength values. This is a clear sign that our antibody is unfolded and thus gives us a way to progress with the rest of the analysis. The other thing to take note here is that we're doing a full spectrum measurement. The SUPR-CM utilizes an array detector that allows us to measure the plates very quickly whilst capturing all the data and at good quality. And because we can use a 96 and a 384 well plate, you don't need to compromise on the number of samples you can measure or the number of data points you're collecting, especially with a 384 well microplate. You can fit, in this particular case, up to 5 different conditions onto one plate and still be able to use a high number of data points and still measure it within 2.5 minutes. So now that we have our fluorescence spectra, we can take the ratio of intensities and calculate our fraction unfolded as we can show here. And you can already tell that altering the pH has had an effect on the stability of the antibody. Looking at the transition region, you can see that changing the pH has shifted the transition region um, differently. And with this as well, we can also highlight the point that utilizing conventional microplate formats, particularly the 384 well microplate, is very easy to scale this up to measure not just 6 pH different cases, but you could look at different buffers or different excipients. It's very easy to scale up this operation to look at multiple different conditions without vastly increasing the time or the cost.